Viitorul e al tău, noi punem temelia. UTCB, construim pentru România. UTCB, Universitatea de Construcții București.
So good morning again, ladies and gentlemen. Today I want to introduce SIP and IHI. On behalf of SIP, on behalf of Project Director Professor Makoto Hisada, and also for IHI, on behalf of Professor Dan Frangopol at the IHI University. So I will introduce what we are doing in SIP and IHI. So in this morning, Mr. Shibata introduced how our bridges deteriorate. Age of bridges in 2023, bridges of older than 50 years is only 39%, but in 10 years, in 2033, it will become 60-30%. So our bridges deteriorate. Also, our problem is aging of Japanese. In addition to aging of bridges, we have a very serious problem: aging of Japanese. So, I was born in 1971. At that time, the total number of babies was 2.2 million. But now, last year, total number of babies was only 0.7 million. Very serious decline. Okay? Also, popularity in construction industry is not good. So in 1997, 6.8 million people are working in the construction industry. But now, only 4.8 million people are working in this field. So we are very facing a lack of labor shortage. Also, in Japan, there are many local cities and towns. It's very difficult to find real civil engineers, bridge engineers. Although they have many local deteriorated bridges, I don't know how to maintain these bridges in local cities. So these are our motivations, why we need this SIP project. Also, I want to summarize our current issues and challenges. So in construction industry, I'm not sure in Romania, but in Japan, our construction industry doesn't like high technology. We love low tech. So, but our government push us. So please introduce more new technology such as automation adoption. And also, as I mentioned, so aging infrastructure was in Japan. So most of the bridges were constructed before 1990. And we had the we had the Tokyo Olympic Game in 2020. So due to COVID, it was actually held in 2021. But the previous Tokyo Olympic Game was held in 1964. Yes. So, and at that time, we constructed many bridges. And so we are facing aging of these bridges. And also, as I mentioned, population decline. So how we can maintain these bridges under these very difficult situations? Okay? Aging of bridges, aging of Japanese, and now we are facing a very serious issue of budget. So I want to introduce some our problem more. So as you know, Japan is located in earthquake-prone region, right? So since 1995 Kobe earthquake, we have had so many big earthquakes with the moment magnitude of larger than 6.5. So in Japan, we say if earthquake magnitude is larger than 6.5, it's big earthquake. because an earthquake with a moment magnitude of 6.5 may damage to bridges. So now you can see so many earthquakes. However, before 1995 Kobe earthquake, we didn't have so many big earthquakes. This is good, but this is not good. I will explain more. So this figure shows a relationship between the number of bridges and the year of construction. So you can see, so this is our economic growth period. So previous Tokyo Olympic game was held in 1964. So we constructed many bridges without the experience of big earthquakes. It's a good, right? Because we could construct many bridges without disasters. However, these bridges were designed without any seismic structural details. It's a serious problem. So our seismic design code was improved after Kobe earthquake. But unfortunately, we already constructed so many bridges. So even though it's very important, right, that rapid progress is made in the seismic retrofit program, but it will take a lot of time. Still, so every time when we have a big earthquake, I will do field investigation and I observe, oh, this bridge failed in shear and this bridge has some serious damage due to lack of adequate structural details. So similar to maintenance issues, aging, we know what is the problem. So I'm a professor of structural engineering, and I'm very interested in concrete structures. And I can say what is the issue of existing concrete bridges. So main part is for ground motion induced damage. I can say all the bridges, if bridges are designed according to design specification issued before 1990, so they don't have enough sufficient shear reinforcement to prevent shear failure, brittle failure. And also structural details are not good. You can see on left picture, this shows the damages at the cutoff of longitudinal rivers. So shear failure and this cutoff failure, these are typical failure mode of RC columns in Japan. And also, all the concrete components, members, have a very difficult problem because they are constructed with very high water to cement ratio. Because they, at that time, they don't know. So if water to cement ratio is high, this must cause very big issues on carbonation or chloride issues. And also, previous concrete structure has very small concrete cover. Very, only 10 millimeter, sometimes 20 millimeter. Now, minimum concrete cover is like 60 millimeter, 70 millimeter, depending on chloride environment. So anyhow, so we know what is the issue. This is four major issues of RC components in Japan. So we know these problems, but it's not easy, right, to maintain, to repair all the bridges. So now we are trying to fix these issues in SIB program with 5 sub-projects, from project A to project E, okay? So budget is really big. Every year we can have about 40 million euro. But our government is very strict. every year they evaluate our activity. And if our activity is not enough, they cut our budget. Very strict. And so now I'm working in this SIP as a sub-project director. So I always need to explain how we are working well to governing board members. Governing board members belong to cabinet office. So to get a big budget, I always need to explain how we are doing well. And also, we have a project manager to control each sub-project from A to E. So I will explain our managing teams members. So program director is Professor Makoto Hisada. Last May, he made a presentation in this room. And also, including me, there are 5 sub-program directors. Also, there are many project managers. So our project is really huge. And these are some core researchers in each programs. And today, I'm very fortunate to be here with my colleagues, Dr. Wakahara, in sub-project E, Smart Infrastructure. So in this afternoon, my colleagues will introduce what they are doing to maintain bridges in Tottori Prefecture. So I will explain some details about each research theme, such as we are developing new vehicles to automatically detect the deterioration of RC slabs. Using these vehicles, automatically we can evaluate the status of RC slabs. And also, as I mentioned, in Japan, we have very serious issues about shortage of labor. So we try to develop some new vehicles to construct infrastructure systems without drivers. Also, 3D printer is one solution, right, to construct like RC collapse. Also, now digital twins are really key. Right? So, from design drawings, automatically we try to develop a numerical model, and we evaluate what's happening in our future. Also, we try to include inspection result automatically into numerical simulation. So, digital twin is one of the core technologies developed in our SIP. But so for new bridges, it's not so difficult, right, to make a digital twin, because now we can use AutoCAD. We can use CAD software, and we can simply combine CAD software with the numerical simulation, such as Abacus or DR. But for all the bridges, it's still a very big challenge. Right? So after I got my master's degree in 1997, I worked at Nippon Koei. It's one of the biggest consulting company. And I worked as a bridge designer. So, but in 1997, still design drawing was paper-based. Japanese love papers. Not so much digitalization at that time. So our big challenge is for new bridges, it's not so easy, it's not so difficult, right, to combine CAD information with the numerical simulation. However, all the bridges, so always design drawings are paper-based. So how to make digital information, it's still a big challenge. Also, in our SIP, we are developing an education system to train bridge engineers. Because now we try to introduce digital twin models, right? So we have to give education for bridge engineers how to use new technologies. But also in countryside, as I mentioned, many cities and towns don't have civil engineers. So we have to have some training system. Also, to apply new technology to real world, we have to have guidelines and manuals. So with working with associations such as Japan Society of Civil Engineers, we are trying to develop some publish new guidelines to apply new technologies to real world. Also, we are doing research on regional management of infrastructure exposed to diverse hazards. So, Romania and Japan have very similar environment. We have a very high seismic hazard. We need to care about the deterioration, like due to de-icing salt. And in Japan, we are island, so every time airborne chloride flies from ocean. So concerning this very challenging hazard environment, we have to develop our maintenance strategy. Also, as I mentioned, I'm working as a sub-program director of SIP. Especially, I'm in charge of international matters. So our government say, let's try to apply our proposed method to other countries, and also let's discuss, right? Because this is a common issue in all around the world, right? Not only in Japan, not only in Romania, in Europe, in the US, China. I have many friends in these countries, and we discussed, and I realized, oh, this is a really common issue in all countries. So I want to discuss to find the solution. So this is one of opportunity to discuss this very difficult issue. So I have many colleagues like Professor Dan Frankopol in the US, Professor Iron Chen, Xin Luan, John Casas, Fabio Biondi, and also I used the name of Raji without getting permission from him. So in this community, I want to find a way, what do we have to do? So I will present one example, what we are doing internationally. In Southeast Asian countries, as you may know, JICA constructed many bridges in Southeast Asian countries. And some of them began to deteriorate. And our SIP team has a very unique inspection method using satellite. Using satellite, and satellite take many images. In addition to information on temperature, they developed a method to measure deflection of structures. In millimeter, accuracy of is millimeter. And using this satellite technology, so very with a very low running cost. And so real-time monitoring can be achieved. So we apply this technology to bridges in Southeast Asian countries. So their bridge may have damage due to deterioration and scours of flood. But for Romania, I want to discuss more about strategy or more big picture of maintenance issues. So as I mentioned, Romania, Japan, we have a very similar environment, high seismic hazard and corrosion environment, and also we have to care about the budget constraint. This is a very old my research outcome, but how difficult to identify dominant hazard. We have to prioritize seismic issues or deterioration. It's very challenging. So in this figure shows two hazard curves. Left side shows hazard map, seismic hazard map. And the right side shows hazard map associated with airborne chloride. In Japan, generally, wind is coming from west. So this side has more high hazard due to chloride attack. And I selected two cities, Sakata and Uwajima. Sakata city has very high chloride attack, but the seismic environment is mild. Uwajima city is facing to Nankai Trough. It's our serious concerns for future earthquake event. So Uwajima city is located in very high seismic hazard, but the marine environment is very mild, which is serious for RC bridges located in Sakata city and Uwajima city. So my computational result is like this. At the beginning, so we have to care about seismic hazard. So failure probability of RC bridges in Uwajima city is high. However, if we consider long-term lifetime, like 50 years, so failure probability of RC bridges in Sakata city is finally higher than that in Uwajima city. So this is just one example, but it's not so easy to say which bridge should be retrofitted first. Okay, so Romania and Japan has very similar environment, so it's really challenging for bridge engineers. So from not only this workshop, but I really want to keep discussing, working with the engineers in Romania how to maintain our bridges, our infrastructure system to ensure sustainability. So in Japan we have several associations, like Japan Association of Civil Engineers, also Japan Concrete Institute. So I asked my colleague in Romania, so what do you have to discuss bridge safety and bridge maintenance? So I couldn't find some big association. So I asked Professor Dan Framopol. He's the president of YAMAS, and YAMAS is an international association for bridge maintenance and safety. So he said, it's a good idea to develop YAMAS Romania group. And so with this association, we can discuss. So as I mentioned in the morning, so professors, officers, and practical engineers in industry, we need to work together to advance bridge maintenance systems. So one idea is, so we will have some core association, and we can work together. We can share our experience and knowledge. So thank you very much, Dr. Vero. So he will be president of YAMAS Romania Group, and last week I asked Professor Dan Framopol to give us some message as president of IAMAS. Now I want to share the video.
Good morning, ladies and gentlemen. Good morning also, Professor Radu Văcăreanu.
You want to see done, right?
Professor Victor Popa and Viorel Gureanu. I am Dan Frangopol, Professor Emeritus at Technical University and at the University of Colorado, and graduated a long time ago from the Institute of Civil Engineering in Bucharest. I am also the president of IAMAS, and I want to say this message to all the participants of the second road bridge maintenance workshop between Romania and Japan. Last year, IAMAS celebrated the 25th anniversary during IAMAS 2024 in Copenhagen, Denmark. Today, our organization has grown to include more than 2,300 individual members, over 100 corporate members, and 50 national groups in countries such as Australia, Brazil, Chile, China, Italy, Japan, Korea, Portugal, Sri Lanka, Turkey, United States, Spain, Canada, Denmark, and Sweden. I believe that through the workshop, participants will recognize the importance of collaboration among central and local governments, universities, and industry in advancing bridge maintenance. A key foundation for such collaboration is the national groups within IAMAS. By connecting with the main body of IAMAS, this group play a crucial role in fostering a global network of bridge engineers, enabling the exchange of expertise, challenges, and innovation worldwide. In this context, I am particularly pleased that my home country, Romania, is now establishing the 16th national group. I strongly believe that IAMAS Romania will serve as a vital platform for bringing together experts and stakeholders in bridge maintenance, facilitating knowledge sharing and make international cooperation. Furthermore, I have great expectations that IAMAS Romania and IAMAS Japan will act as a bridge in promoting technical exchange between Romania and Japan in the field of bridge maintenance and safety. Again, I want to thank Radu Văcăreanu, Victor Popa, and Viorel Gureanu, and also especially to Professor Akiyama. He is the secretary of the IAMAS Executive Committee and did a lot of work for this association. I look forward to attending the first event of IAMAS Romania in person as the president of IAMAS. I wish all participants a productive and insightful workshop. Thank you very much, and I'm sure this workshop will be very successful. Thank you.
So thank you, Dan. So I believe this kind of association help us to discuss more efficiently. And also, even if I have published many papers at some good journals, including engineering structures and structural safety. However, even if professors develop some new technology, it's not so easy, right, to apply to real world. So this kind of association help us to advance maintenance of bridges. So let me introduce IAMAS briefly. This is our field of activity. Mainly, we are discussing maintenance issues. Of course, sometimes we are discussing seismic resilience, also life cycle cost. But our target is more maintenance issues. This is a mission, objective, activities. Also, our association is strongly related to international journal, structure and infrastructure engineering. So if you have some good result or research outcome or some good case studies, so please submit your paper to this journal. So this is our home page. So now I'm webmaster of this association. So this association is really good because membership fee is free, totally free. So let's join Yamas. And first, please send your application from here. Join Yamas. Okay, and please input your personal information. And your application will come to my email server. And then we will approve your applications. And then you can be member of Yamas. In addition, you will be member of Yamas Romania group. Now, as Dan mentioned, the number of individual members are like about 2,300 people. And we also have, this is individual members from which countries? Japan is the fifth country, and Romania is there. About, at this moment, about 20 to 30 members from Romania. Also, we have 106 collective members. And every 2 years, we have international conference. So first conference was held in Spain, Barcelona, in 2002, and going to Kyoto in Japan, and Portugal, blah, 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 blah. And so last conference was held in Copenhagen. And we celebrated the 25th anniversary of Yamas, as Dan mentioned. This is a prize. Every 2 years, we give some prize. This is the history of Yamas, very, very old one. And this is the Yamas in Italy, Shanghai, Brazil, Melbourne, and Japan. Unfortunately, due to COVID, this was an online conference. And Barcelona, and last, after Barcelona, we have to 2024 in Copenhagen. And the next one will be held in Florida, in the US. This will be held from July 7 to July 10 in 2026. So they will announce when is the deadline of the abstract and when we have to submit the full paper. They will make an announcement very soon. But anyhow, so if you are interested in this association, please join. So as Dan mentioned, now we have 15 national groups. First group was Portugal, blah, blah, and the latest one was Yamas Sweden group. And now I'm always making this slide when we have a new national group. Now I have to make a space for Romania. So I have to ask Canada, move to left. Denmark, please move to left. Sweden also, so I can have a space for you. Yes, Romania. So thank you. Yes, and now we can have 16 national groups. So bridge maintenance requires many aspects, right? And also government officers, university professors, practical bridge engineers need to work together, right? If we only focus on database in government, it's not enough, right? We have to use database, right? And also, even if professor develop some new method, this is not enough. This is just research for research. So with the core association like Yamas Romania Group, Yamas Japan, and also SIP, we want to discuss how to work together to maintain bridges in Romania and Japan. I hope this workshop will be first step, and I want to keep discussing to pass on a sustainable city to future generations. So thank you.
We have 5 minutes for question and answers if you want to ask any questions, please.
Which one?
Please.
Not a problem. I see in your presentation you have a lot of personnel specialized in the area of inspector of the bridges and to construct or to repair. Now the situation is the same.
What do you mean? Method?
You have not enough personnel for take the inspection for the bridges after the constructor which repair, maintain the bridges. Is the same situation now, or you intend to give some extra money or something which is...
Yeah, it's a same situation. So we can evaluate okay, so this bridge should be repaired immediately. But sometimes due to budget issues, so local government cannot do it. So then we believe we need to care about the importance of bridges. We cannot repair and retrofit all bridges simultaneously. So our SIP team will give you some method to prioritize.
This is the same.
Yeah. Yes.
Okay, in the field of the engineers specialized in the bridges, you have a prestigious university, but the number of the students and the number of the engineers which is prepared is increasing or decreasing?
So number of bridge engineer, you mean?
Yes.
So our population decline. It's impossible only bridge engineer increase, right? So our focus is more we try to develop technology. We can construct infrastructure systems with more like robotics or more with labor, less labors. So this is our target, considering decline of engineers.
It's very good, but I remember you said you make the design on the paper. It's very good. But anyway, with the satellite, which is the error of the measurement?
Oh.
It's a millimeter. It's very easier to...
But so this technology was developed by NEC. It's like a computer company. Yes, and they say the resolution is not enough, right? And using many pictures, combining many pictures, and also considering the effect of temperature, they developed a method to estimate deflection in millimeters. And also they calibrated. They validate their method is really correct. And so now I think this is a really promising method to identify which bridge should have, may have deterioration. So now we are trying to apply this technology to real bridges. And also this trial gives us some validation of method.
Okay, very good.
Excuse me, we have 2 or 3 more minutes. There will also be a roundtable discussion in the afternoon. And there were also
Okay.
2 more questions.
Okay, thank you very much.
Please, you also have a question?
We have time, if not.
We have
Okay.
a little
I have
bit
2
of time.
questions. One, regarding the maintenance, because we have the same similar climate, also earthquakes, and in heavy winter. I believe you have also this situation.
Yeah.
What kind of materials are you using? We use salt and sodium chloride for defreezing and have the surface of the road clean. But salt is not the best solution for concrete. You have other materials or?
Of course, like stainless steel could be one solution, right? Stainless steel, material property of stainless steel is very close to carbon steel. So this could be one solution. And also now we are developing some non-metallic rebars. So these non-metallic rebars can be used to concrete structures in chloride environment.
Second question, from this 7,020,000
Huge bridges.
you have around 60,000 bridges that are included in class, third class and fourth class. For these bridges, how long it takes from the moment you start the documentation, the design papers and the authorization until you start the execution?
So
Years, 1 year, half a year?
So, like if a bridge is categorized to a level 3 or 4, so according to our regulation, it should be repaired before next inspection. So it means within 5 years. But actually, sometimes it's really difficult, correct? Yeah, regulations say we have to do it soon, but
Because it means capital repairs, third and fourth class. We have the same problem. And
yes,
it takes a lot of time.
yes,
The project and the execution and repair, the capital repairs.
yes. And also, category 3 and 4, this doesn't say bridges have sufficient seismic performance. This evaluation was just based on deterioration, right? So we have to care about both seismic performance and deterioration levels. And we have to select which should be first repaired or retrofitted. But it's a really challenging topic.
And you obtain the authorization and all the papers very quickly, or you have some steps?
What is your point?
The paperwork for
From
the
medium
construction.
Paperwork?
So to get permit for construction, to get permit for rehabilitation, the paperwork,
Yeah.
does it take a long time or do you get it immediately?
About what? About the decision?
I think this is a question for the government, not to Professor Akiyama.
autorizații de numele
Yeah, I
de
think-
apele române.
Știu ce spuneți, numai că domnul este profesor la universitate.
Okay.
Va fi, so there will be a presentation from the Ministry of Japan and of course you can ask them.
Yeah.
I think you also had a question.
I have one simple question. Sustainability is a big issue in the field of bridges and infrastructure. And my question is the following. It's very clear that use phase in case of bridges is more demanding than use phase in buildings. In this sense, you create a database of information. How you transfer those information to the new projects and how you select new materials and new solutions for this.
Yes, so every time we collect information from real bridges, and some information clearly say thickness, for example, the thickness of slab is very important to prevent fatigue of due to traffic. So every time they update the design specifications based on observations. And every time, so observations, and we obtain some new knowledge and lessons, and we update design specification for new structures. We need to repeat this process.
Yeah, I will have some more comments, but we will discuss it.
Okay.
Thank you.
Okay.
Thank you so much. From now to 1:15, we will have a lunch break. I invite you to the same location as the coffee break. So please gather back from 1:10 or 1:15.
Okay.
Thank you.
Thank you.
Thank you so much.
UTCB, viitorul e al tău, noi punem temelia.